landings, 3 LZ2, and 3 LZ4. The 3 LZ2 landings were the Falcon Heavy landings, Thomas, right? Yeah, cool. So I'm going to switch this over to Science and Technology. SpaceX Falcon Transporter-2 Launch coverage. All right. Transporter-1 landed next to the Bahamas. Yeah. Girlfriend and I were in Florida for the CRS-20 mission. Yeah, Max, it's seeing them come back and land is something everybody should see if you like rockets. That is one of the weirdest things ever. It's one of the strangest things. Seeing them come back and land. It doesn't look right. Like, but then again, how do we know what that looks like? We've never seen that before, you know? SpaceX stream is starting up. Perfect timing. Perfect. Where is it? Ah, here we go. All right. Got it, Mutter. Thank you. Yeah, Aiden, it's really cool. Like, I've seen 2 of them land at the same time. I saw Falcon Heavy RTLS, and it is just strange. It's just strange, man. No ASDS stuff for a bit, though, since GoQuest is out of the water right now for maintenance. Hey, Jam, what's going on? It moved my pants. Oh yeah, I saw the lift shaft of a building site that was 15 stories high. The drone ship footage makes the first stage look way smaller. Yeah, serious. That's something that I really try to drive home with people when we're doing like space news and stuff, is the scale. Your brain is telling you how big Falcon 9 is, and it's probably about 1.5 times bigger than what the average person like expects. The thing is 15 stories tall. A fully stacked Falcon 9 is 220 feet, so that's 22 story. It's a 22-story building. These rocket and Falcon 9 isn't even that big of a rocket, like comparatively. Like if we do rocket comparison, right? Falcon 9 isn't that big. And, okay, that's not to scale. There you go. It's not the biggest rocket around. It's not the smallest, but it's not the biggest either. I mean, this has a lot of outdated... That's an outdated picture. Like, check that out. Like, look at it compared to a Saturn V. Nice, O-Force. Hell yeah. I mean, here's Starship, Block 2 SLS, Saturn V N1, SLS Block 1, Long March 9, Yenisei, and Energia. Like, it's a big rocket, but it's not the biggest rocket. Some of these rockets are just on a scale that's incomprehensible. Oh. Looking pretty good. Here we go.
Ready for launch. Ignition. Liftoff.
Saturn V, you say? What's up, Savvy? Here we go.
8.
Let's see some RTLSs today.
6, 5.
I saw that.
4, 3, 2, 1.
Sneaky, what's up, man?
Good afternoon. It's Wednesday, June 30th, and we're here at SpaceX's headquarters in Hawthorne, California.
Andy
You're
again.
looking at a live view of Falcon 9 as it awaits its 3:31 p.m.
Jimbo.
Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. My name is Andy Tran. I'm a production supervisor here at SpaceX. Welcome to the webcast for SpaceX's Transporter-2 mission. It's our second dedicated smallsat rideshare program launch and second launch, or 20th launch of 2021. For those of you who joined us yesterday, you know that we got all the way down to T-minus 11 seconds, but had to stand down from our launch attempt due to rotary aircraft entering the keep-out zone. We are expecting the airways to stay clear today and looking forward to having Falcon 9 deliver the 85 spacecraft and 3 Starlink satellites on board to orbit. Now this includes CubeSats, microsats, and orbital transfer vehicles, sometimes called space tugs, which will deploy their spacecraft after separating from Falcon 9. Today's launch is SpaceX's second polar orbit launch from the East Coast, and only the second polar trajectory since the late 1960s flown out of Cape Canaveral. A polar orbit is one in which satellites pass above the North and South poles as opposed to the equator. SpaceX has worked closely with the Air Force and the FAA to create a trajectory that meets the necessary safety requirements for flight. So far, everything's looking like a great day for a rocket launch at the Cape, and with liftoff in just under 10 minutes, let's take a closer look at Falcon 9.
It's the 8th flight for this booster, guys.
The 2-stage vehicle is standing about 229 feet tall, or slightly taller than a 21-story building. It's named after the Millennium Falcon from Star Wars, and the number 9 indicates the number of Merlin 1D engines on the first stage. Today's mission is the 8th flight for this particular booster. That bottom 2/3 of the vehicle is the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere to space and then separate from the rest of the rocket. From there, it will make its way back to Earth and target a landing on land this afternoon on landing zone 1, which is the pad that you see on screen right now.
It's an old Atlas Agena launch
And if you're an
complex.
Eastern Florida resident, you might even be able to see Falcon 9 over the ocean, or also hear one or more of the sonic booms as Falcon 9 makes its way back to land.
Polar orbit is harder to get into.
The first stage is the black carbon fiber inner.
So Andy's just going to describe the rest of the rocket. You have the inner stage here, and then the second stage engine is riding inside of it. It's a hollow cylinder, and then you have more hollow cylinders up here. Second stage, and then there's like a Lego kit of satellites here. It looks like a Jenga tower. I wonder if they'll show the payload attachment fitting. And then the aerodynamic fairing at the top, which is a clamshell style fairing, which opens like that. SpaceX has reused those fairings before. Hey, bloke, 37-month resub. Didn't that go through yesterday, dude? Physics out. 28 viewer raid. Thank you very much. Yeah, and I agree. So alleviate. Yes, it is harder. It requires more delta V to get into a polar orbit. The reason is because, you know, where this is at 27 degrees in north latitude, it's still close to the equator, so you're spinning. When you go into a polar orbit, like the Earth is spinning and you launch, right? And you have to go. You basically have to launch south, but you also have to counteract the spin. So you kind of have to launch southwest a little bit. So for this mission particularly, they have to launch southeast. The rocket has to go up, go around Miami, right? Southern Florida, and then take a left or take a right as it passes Miami heading southwest. Going out and doing that kind of dogleg track is what SpaceX is going to do to counteract the rotation, right? The vehicle probably has because of Earth's spinning, it's, what is it, like a 400 or 500 meters a second velocity going left to right. So if you're trying to launch due south, you have to counteract that. So take the amount of delta V that you need, and if you want to get into a polar orbit, add a half a kilometer. Probably not an extra kilometer a second, but I mean, well, you're not. The other thing is that you're not totally counteracting the spinning force. You're going perpendicular to the spinning force, so it's not that much. It's probably an extra like 200, 300 meters a second, something like that, on top of like 9 kilometers a second. Falcon 9 is capable of doing it, easily capable of doing it, but it's still a nutso trajectory, like in a good way. It's pretty awesome. This one is RTLS, yes. Beltbox, 57-month resub, thank you. Why not launch from Vandenberg if they're going polar? I think, Taco, they just had the stages here, and you're cleared for, they're cleared for, so a couple of things, actually. It's logistics, long story short. They're cleared for a polar orbit trajectory with the rocket out of the Cape, so they can do it. The stage is already here, and there's no drone ship out on the West Coast. You could RTLS from the West Coast site if you wanted to, but I think it's just really a matter of there's more Falcon 9 stages here, so launch it here. Does it make a difference? Right? That saves you a trip from busing a first stage all the way across the country. Return to launch site is what RTLS stands for.
Discovery, go at throttle up.
Alright, we'll fast forward a little bit. Radioactive, 75-month resub. Thank you very much. Physics O, thank you for the raid. I do appreciate it. Who's coming in from there? Anybody coming in from Physics O? I don't know Physics O very well. Or if at all. Physics, if you're here, introduce yourself, please. Don't be a stranger. Don't raid me and then just bees out. Don't do that. Tell me about yourself. So, yeah, Taco, it's really just logistics, I think. I'm pretty sure. With that being said, SpaceX is moving, of course, I Still Love You, over to the West Coast. So, they are going, you're going to see an increase in launches out of Vandenberg for Starlink and other things, other things. Hi, I'm Physics. I do physics. I like physics. Physics is cool. Ci sono, come stai? Bene. Molto bene. Grazie. Might be also the case some customers don't have access to Vandenberg. I don't know if that's a thing, God, but maybe. D-Pick gifted a sub to Physics O. Thank you. And then Pizza King had a 14-month resub in there, too. Love Space. So this is awesome. Yeah, I am, in fact, a fan. If you don't know me, Physics, I'm kind of a space nutcase. Makes sense. I just wanted to see a launch this summer before I head back up to the Pacific Northwest for school. Yeah, I got you, man. I got you. Ismail, 32-month resub and need backup with a Tier 2 71-monther. Thank you. Why is the fairing so shiny? It has thermal protection on the top, but those fairings are reused. They've been scuffed up a little bit. Yeah, look at that. Look at on this side. It's got the ragged old flag on it. I tell you, I'm mighty proud of that ragged old flag. She launched on the Falcon 9 fairings. Surfed through a wave of fire, but she's okay, though. Anyway, I can't keep up with all the resubs. Tape had a 15-monther in there. Deadly Spoon had a 41. Dangerous had an 8 in there. I think that's all of them. John, I'm trying to see your last, but I can't find it. Wouldn't a site like Alaska be better due to less sideways motions? Yeah, and that's why there's a launch site in Kodiak. Kodiak, Alaska. The U.S.'s 4th Space Center is there. The U.S. has 4 primary launch sites. There's the Cape, there's Wallops, Vandenberg, and Kodiak. They do a lot of missile testing out there. How's the stream thus far? Ran, I can't complain, dude. Randy, 52-month resub. Thank you. Yeah, that fairing has been into space. It's been scuffed up. This might look like the kind of regular soot that's on Falcon 9, but that's plasma scoring. Yeah, I can actually say that. And no, it's not something from sci-fi. Plasma is what's causing that scoring on the booster. It's burning it up because air is getting compressed against the fairing as it re-enters. And that resulting compression creates a lot of heat. And it gets to the point where the air molecules are getting ionized. They basically rip apart, and that resulting split, the ionization creates plasma during re-entry. So yeah, that fairing has been scuffed up a little bit. It's actually been up into space a couple of times. Check your last. Yeah, I'm going to try to, Velo. Yeah, well, not try to. I'm going to. All right. Thanks for the gifted subs. Flight Sim gave out 5. Tape gave out 5. D-Pick cheered 100 bits. I'm going to tune back into the audio. And
when the dense, cold liquid oxygen meets the warmer ambient air of Florida.
So now what they're doing here, they're draining out the transporter erector's fuel lines. The T has the fuel lines for the second stage. You can see the second stage umbilical right there. That's where they load liquid fuel and RP1 into it. And what they do is during launch.
Falcon is in startup.
Okay, we're in startup here. What they do is right before launch, they get all the fuel out of the pad. That's what that is right
Here
there.
in Hawthorne, the first and second stages are beginning
Jinsey,
to pressurize
love him at 3
launch.
sub.
Discovery, go at throttle up.
Great way to watch launch coverage here. Huslik, Gross,
Falcon 9, Transporter-2, LDs go for launch.
Danke.
That was the launch director giving the final go for launch.
Okay, LD says
we
we go for
are
launch.
T-minus 30 seconds from
Cookie
liftoff.
cart,
Let's tune into terminal
13
count
monther,
and
and
watch
grits and
as the
gravy.
Transporter-2 mission begins.
Thank you. There's more bits in there. Chat is go for launch. Do they add ground anchors in KSP? Yeah, the hotfix came out yesterday.
T-minus 15 seconds.
Okay, here we go. Watch the sound suppressor. It should turn on. This should
10,
should start seeing
9,
water come out here.
8,
Discovery,
7,
There it is.
throttle up.
6, 5, 4,
Stand by for ignition.
3, 2, 1, 0. Ignition.
We're flying. Here we go. 8th flight for this booster. Polar RTLS. Transporter-2 is in the air.
Vehicles pitching downrange.
Pokey gifted 5 subs. Thank you. Let's go. Okay, so right now, this thing is going to go initially out to the east a little bit, and then it's going to take a turn south. So it's going to, if you looked at the track on a map, it would look like it's going this way and then takes a right. It takes a dogleg trajectory, because it needs to fly around Miami.
First stage chamber pressure is nominal.
Okay. Booster officer is reporting good chamber pressure.
We are T plus 42 seconds into flight. Falcon 9 has cleared the tower, and we're currently throttling down
Oh, okay.
in preparation for max Q. That should be coming up in about
Everything
20
looks
seconds.
okay, John.
Max
I'm
Q
not-
is where
I
the
don't see
vehicle will
anything
experience
weird.
the highest amount of aerodynamic pressures.
Falcon 9 is supersonic.
Okay, breaking the sound barrier in less than 60 seconds. This is a Polar RTLS series. Yeah, it's going to be insane. This is going to, the views are going to be
Max
ridiculous.
Q.
Okay, maximum dynamic pressure.
You heard the call out. We've passed the period of maximum aerodynamic pressure. Falcon 9 is now headed south
What's up,
along
Greg?
the
How you
Florida
doing?
coast. All is looking good with the first stage trajectory. We have 5 events coming up in quick succession in about a minute. The first is main engine cutoff, also known as MECO, followed by stage separation, where the 2 stages will separate from one another. The first stage will then perform a flip to head back towards Florida, and
What was that camera?
the MVAC engine on the second stage will form second engine start 1 and ignite that MVAC engine.
All right, so we got
And
the
first
trajectory over
stage will
here,
also
and then we have the
begin its
onboard over
first
here.
of 3 burns.
So
the
check it
boost
out.
back burn.
See how initially it's going this way, and then it's going to go down that way.
And this is a view from the top of
Dankaroni?
Falcon 9 looking down towards the 9 Merlin engines at the bottom of the first stage.
Yeah, it looked like a drone, yeah. So it's crazy because the first stage, when it's gonna come back, is gonna aim out here somewhere, and then after its entry burn, it's gonna turn, and that first stage is gonna fly, and it's gonna fly back. It's gonna do the boost back burn out over the ocean, or the entry.
Stage separation confirmed.
Okay, Nico and stage sep confirmed. There it goes. First stage is going to aim out here, and then the grid fins are going to steer it back into the launch pad, which is cool. There's the first stage over there on the left.
And there you saw on screen we had successful stage separation. The first stage started performing its flip maneuver,
Okay, first stage is boosting back.
and the boost back burn should be ending in about 25 seconds.
So right now, the first stage isn't so much turning around and trying to boost back towards the launch site. It's, once again, it's aiming out in the ocean somewhere. But also, because the first stage is up in the air, Earth is spinning underneath it. So Falcon 9 isn't so much like going up and then turning around and coming back. It's actually boosting back, and it's actually turning to the right. The first stage
Stage 1 boost back shutdown.
The first stage is actually aiming
And
out
there
in
was
the water.
confirmation of a successful boost back burn.
The reason why it's aiming out in the water is because the Earth is going to spin underneath it, and they want Falcon 9 to come back down right near KSC. So it's not so much aiming right for KSC right now, because if it did, by the time it got back down there, it would be first stage would land somewhere in Orlando. Stand by for the fairing separation. Look at all the different satellites.
And
on there.
off come the 2 fairing halves. And they
So,
have separated and fallen
it's actually
away from the
kinda
vehicle,
taking a
exposing
right
the
and
88
boosting back at the
spacecraft to
same
the
time.
vacuum of space. As a
Crossing.
reminder, the recovery vessel
And then
HOS
Decaroni.
Briarwood will be attempting to recover the fairing half today from the water. So we are about T plus 4 minutes and 20 seconds into flight.
See,
We
you
have a
can see the
couple of
track.
views on screen. On the right-hand side is a view
The
of
track
our
went
second
this way,
stage
and then it went
Merlin
down.
vacuum engine, also known as the MVAC engine. It's currently in the first of 2 MVAC burns. This burn
Correct,
should
Lucio.
last for until the T plus 8 minute and 24 second mark.
Yeah,
About another
KFC.
4 minutes
Well, I mean,
left
we
on
could
this
land there
burn.
too if we wanted some chicken, Warhawk. I mean, it's up to you, man. I don't know. Not
And
really hungry.
the next milestone will be for the first stage to perform its entry burn. That's what you're seeing on the left-hand side of your screen. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere.
So right now, the
and
first
without this
stage-
burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket.
Vehicle is on a nominal trajectory.
Everything's looking good.
The call out for a nominal trajectory. Everything's looking great so
Here,
far
look at
on
the
the
track.
Transporter-2 mission.
So you can see the track being projected on the ground. It went out this way, and then it's going down. And right now, the second stage is kind of doing a corkscrew. This is the projected track. That's where they want the vehicle to go. And then the blue
You
lines are
also
where the
notice some
vehicle's currently going.
honeycomb-like structures have
Notice as
deployed
the second
on the
stage-
first stage on the left-hand side.
As the
Those
second
are
stage
4
keeps increasing
hypersonic
velocity,
griffins
right,
positioned at the
that
base
blue
of
line
the
gets
interstate.
closer to the
They help to
projected
orient
track.
the rocket during re-entry by moving
This
the
also
center
is the
pressure.
trajectory from the next orbit.
There's also
But if
some
you see the
plumes of
first
gas coming
stage,
out. This is cold
see the first
nitrogen
stage?
gas, which helps with
When it did the
attitude
boost
control.
back, it's aiming
Both
out
are
here
essential
somewhere.
to make sure
But
that
as
we have a
Earth
nice
spins,
targeted
right,
landing back on
it'll
landing
come
zone
right
1
back
later on
down
in today's mission.
over here, but KSC will move into position because the Earth is
Second
spinning.
burn, the
It's such a weird
entry burn is
trajectory.
coming up in about
Weird ballet
30
of
seconds. Watch for that on the
machinery
left-hand
going on
side.
right now.
You can also see there's a speedometer of sorts on the bottom left-hand side. That tracks the speed of the first stage, and when we begin the entry burn, we'll start to reduce
can't see the
speed,
cursor?
and shortly after the entry burn
What are you talking
ends,
about?
we'll hit the denser parts of the atmosphere and also begin to further reduce our velocity as
It's gonna
the first
land at
stage
landing
continues
zone
to
1.
make its way back towards Earth.
That's bizarre. Anyway. Okay, so first stage,
Stage 2 FTS is saved.
flight termination system on the
Stage 1
second.
entry burn start up.
Okay. Watch this. After this
There's the
first,
call out, and you can see on screen 3 Merlin engines.
after the first stage finishes this entry bird, the grid fins are going to do this, and it's going to steer this thing in. It's crazy. The Falcon 9's almost going to fly back like an airplane. Not exactly. More like a guided munition than anything. But still, it's gonna. The grid fins, you'll really start to see them do work here in a second. Okay, watch.
And successful completion
See?
of our
Did you
second
see how they
of
move
3
like
burns.
this? Watch, this thing's gonna take a huge
As I mentioned
turn.
earlier, we are going to be attempting to recover the booster
Supersonic
for an
retro.
8th time back on land at landing zone 1. The first
Stage 1
stage
FTS is saved.
has 1 more burn left, the landing burn. It begins just before we touch down and provides the booster with a soft descent before we land. At the same time Falcon lands, we are expecting Sequel 1 of our second stage. That's second engine
Look at the
cutoff.
aerodynamics doing their thing.
And shortly after that,
See how
we'll
the
be
grid fin
entering
is
a
doing
coast
this?
phase.
That means the atmospheric pressure is moving back up.
And you can see
Stage
the
1
Florida
entry transonic.
coast and
Okay.
landing zone 1 are
Dude.
approaching on the left-hand side of the screen.
Okay, there's the
as
landing site.
This booster
Watch.
makes its attempt to land for an 8th time.
Oh, look at it steer! Yeah! That's
This is a
amazing!
great shot
Oh, come on, dude!
of the first stage coming down with its landing burn.
Stage 2 internal guidance.
Dude, I told you that thing was flying, man! Falling with style. Sonic booms right there. Oh no.
Stage 1.
Oh no, they didn't.
Like deployed.
Legs deployed. Buttery landing right there.
That was
Buttery
as
landing.
smooth as I'd seen it. We had phenomenal
Oh,
shots
that was
all the way
freaking
through the
rad,
landing burn.
dude.
You heard the sonic
Oh
booms.
my goodness.
This booster has landed for the 8th time.
Oh, that was sick.
That is the 89th
God, this never
recovery
gets
of an
old.
orbital class rocket.
Stage 1 nominal landing confirmed.
That's so good, man.
And what a way to start
Nominal
off the
orbit
Transporter
insertion.
2 mission. At the same time, we did
Dead
have
center.
successful second stage,
Bacon.
second engine cutoff, and confirmation of a nominal
They
orbital
showed
insertion.
the rocket coming down with
We
Slick
are now
36
going to
in the-
coast for the next 45 minutes or so while we wait for
Oh
second
my
engine
God.
start 2. Just a few minutes after that, we'll begin to deploy
That was
the 88
butter-
spacecraft
buttery
on board this
smooth.
mission. We will see you back here around the T plus
Did you
53 minute
did you
and
see
30,
how-
30-second mark.
Oh, did you? I gotta show you again. See, that's what I mean. You couldn't tell so much from the first stage, from the onboard first stage. But right when it started the landing burn, you could see that that thing was flying sideways. Falcon 9 was turning like this, and it was coming in like that. And then it turned in for the landing burn. It was nuts. We gotta see that again. We gotta see that again. Hold on. Hold on. We gotta see it again. It's just coincidence, BD. It's dead center username, yeah. Isn't it cool how it's routine? That's right, Mind Drive. Dude, I'm telling you, the grid fins turn, and dude, this thing, it doesn't look like it, but the thing is flying like this. It has an angle of attack that's like minus 40 degrees, which, I mean, don't get me wrong, that's still a nosedive by plane standards, but for a rocket, that's ridiculous.
This is a great shot
Oh,
of the first stage
Is
coming
this
down
violating
with its
terms of
landing
service?
stage.
Stage 2 internal guidance.
this is too dank for Twitch. Oh, that's amazing. Oh, that's so damn cool. And they showed it coming down near Slick
Stage 1,
36.
London leg deployed.
That
Dude.
was as smooth as I'd seen it. We had phenomenal shots all the way through the landing burn. You heard the sonic booms. This booster has landed for the 8th time. That is the 89th recovery of an orbital class rocket.
Stage 1, nominal landing confirmed.
And what a way to start
Nominal
off the
orbit insertion.
Transporter-2 mission.
You kidding me right now? What was that blue flame that I saw? I don't know. Highest reuse number to land in a landing zone. There you go. Is that nuts, dude? Polar RTLSs are a treat. I mean, look at the angle of attack here, man. So, okay, here, check this picture out real quick. So, there's Cape Canaveral Space Force Station, right? Okay, so that's Slick 37. There's LC 34, 20, 19, 18, 17. And then there's 14, 13, 12, and 11. So Launch Complex 11, 12, 13 is the landing site. There's the landing pad right there. 14 is where Mercury Atlas launched. And then we have 17, 18, 19, and 20, which are old Titan pads. Saturn 1 pad, Saturn 1B pad. And you can't see the pad where this thing launched from. It's over here. Slick 40 is right there. I don't think we can see it.
At the
before it
same
comes
time,
through the
Falcon
clouds.
lands. We are expecting Sequel 1 of our second stage. That's second engine cutoff.
All right, so
Shortly after that, we'll be
yeah, you
entering
can't
a
see
coast
it.
stage.
You can't see it. 40 is over here. Clouds are too low. With that precision, I trust that thing landing in your backyard. I mean, yeah. Oh, that's so cool. I mean, look at the angle that
And
this
you can
thing's
see the
coming in
Florida
at, man.
Coast and landing zone 1 are approaching on the left-hand side of the screen as this booster makes its attempt to land for an 8th time. This is a great shot of the first stage coming down with its landing burn.
Stage 2 internal guidance.
I don't know username. I've done this in KSP, Taradra.
Stage 1.
And then this shot right here, this is kind of funny. This is a shot that's south of the landing pad, looking north. And so, no, actually, I'm not 100% where this shot is. Yeah, it has to be. That's Blue Origin's launch pad. That's New Glenn's launch pad. Oh my god. Is that... Did they do that on purpose? The angle is perfect. It looks like it's landing on... Oh my god. That's so ridiculous. Oh, yeah, so New Glenn is scheduled to launch from this pad. No, let me look. This actually might... This might be north looking south. It's hard to say. If the HIF is over here, then yeah, this is actually up north looking south, not south looking north. But actually, yeah, this has to be north looking south. Does the booster... Yeah, okay, so the heat is in front of the water tower. So yeah, the landing site is over here. And yeah, okay, so this is... I said it was south looking north. It's 180 degrees because the booster's coming from the wrong direction. Water is left, so looking south. I know, Mutter. Geography and stuff, right? Yeah, right.
That was as smooth as I'd seen it.
That's nuts, man. That's ridiculous, dude. 15 stories tall. All right. Can I just see this one more time, please? So the second stage is coasting right now, guys.
To land for an 8th time. This is a great shot of the first stage coming down with its landing burn.
Stage 2 internal guidance.
Oh my. Oh. I know. Yeah, WD-40, you ain't wrong.
Stage 1. London leg deployed.
Hands? No, Joe. No. It's fine.
That was as smooth as I'd seen it.
How much bigger is Booster 3? Greg, the super heavy booster is about 2.5 times wider, and it's about this tall. But give or take, it's a little over 20 stories tall, and it's about 30 feet wide. This thing is about 12 feet wide, give or take. I know, Casper, it's going to be amazing. If you go to the part in the video where stage 1 separates, yeah, I know. I pointed it out, dude. Yeah. Here. You ready? And boop. Should start flying away. There it goes. Oh, that's so ridiculous.
And there you saw on screen.
Yeah, Starship's first stage, guys, is about as tall as a full Falcon 9 stack. Yeah, so here, I brought us back up to live view here. That's just... Polar RTLS. Look at the track, dudes. I'll back us up a little bit. Look at that. Flew out over Cuba, and then flew over... what is that? So Panama is right there. Honduras... in Guatemala, I think. Been a little while. Costa Rica, nice. Rare opportunity to play South American GeoGuessr. Yeah, right. It's cool. And then Venezuela's right there. Bolivia, and Brazil's over here doing Brazil things. I know, Tech, isn't it nuts? And then Chile is over here. Colombia, not Bolivia. Bolivia's south of that. Yeah, it's right here. There you go. The rocket's flying kind of near you, Nick. And then Paraguay and Uruguay are over here. Argentina. Brazil is over here. What is it transporting? There's a bunch of small sats in here, foe. Point Nemo is visible here? I'm not sure. Yeah, Solo. So the transporter is moving a bunch of what are called cube and small sats. A cube sat is like about the size of a shoebox, and a small sat is about the size of a car engine. Yeah, Tech, it's pretty crazy, huh? It's about time, dude. Everyone on Twitter saying that's the best landing they've ever seen. I want to see NASA spaceflight's footage of this. Yeah, Kuru, French Guiana is over there. Actually, it's right... There's the estuary. It's right there. Is this KSP music? I don't think so. Well, the booster's getting a wash. Oh, pfft. The rain held just in time. See last. Cal Poly Pomona is looking to do a 12-view CubeSat soon. Cool. NSF didn't apparently get any video of the landing. Ouch. CubeSats can be larger than a shoebox. They're just divided into units of 1U, 10 by 10 by 10. Good to know. Look at the grid fins as it switched to the zoom cameras. I saw it. You saw the vapor? The vapor cone's coming off. I did see that, Joe. Jeff who? You know what, Joe? You know what the funny thing is? Everybody gives Jeff Bezos crap. Everyone does. Everyone gives him crap. That guy's constantly getting crap from all angles. And you know what? He doesn't care. You know what? You know why? He's the richest guy in the world. Alright. That guy gets crap from all angles, but you never see him say, no, don't say that. Nope, nope, nope. Straight up, no fricks given. It doesn't care. He doesn't care. I'm the richest guy in the world. Doesn't matter. See the link. Did Trevor get a good picture? Oh, yeah, he did. Yeah, he did. Congratulations! You did it! Come on, Jeff! Get him! It straight up doesn't care. That's kind of admirable, to be honest with you. But then again, you know, like... Elon tweet. What do we have from the Elon machine? What's he up to? Great shot, by the way. Starship Super Heavy will not have an entry burn. Delta V is shifted more to the ship, so booster entry pressure and heating is lower. Crazy. That's crazy considering it's methane, which is unbelievable. Oh, I missed it? Oh, Blackbird. No. You know what? I'm not going to pass up an opportunity to show this again. The launch and everything was all fine and dandy. Watch this. Watch from the entry burn down. It is, dude. Just watch.
This burn is expected to last for another 15 seconds or so.
This will mess with your head a little bit.
Vehicle on a nominal trajectory.
Watch this.
Stage 1 entry burn shut down.
And successful completion of our second of 3 burns. As I mentioned earlier, we are going to be attempting to recover the booster for an 8th time back on land at landing zone 1. The first stage has one more burn left, the landing burn. It begins just before we touch down and provides the booster with a soft descent before we land.
Wait for it.
At the same time Falcon lands, we are expecting Sequel 1 of our second stage.
This just happened. This was like less than 10 minutes ago.
Shortly after that, we'll be entering a coast phase. And you can see the Florida coast and landing zone 1 are approaching on the left-hand side of the screen as this booster makes its attempt to land for an 8th time. This is a great shot of the first stage coming down with its landing burn.
Stage 2 internal guidance.
Oh my. Hands. No, Joker. I'm good. Why, John?
Stage
What's
1,
up?
landing leg deployed.
That was as smooth as I'd seen it. We had phenomenal shots all the way through the landing burn. You heard the sonic booms.
I don't know, Thomas.
This booster has landed for the 8th time.
That'd be
that
kind
is
of cool.
the 89th recovery of an orbital.
Oh, that was, dude. So the second stage is coasting right now, so we're going back and watching a little bit of replay here. It seemed there were extra flames to the right, but I could be wrong. Okay, can you give me a timestamp? Like right at liftoff? Let's take a look. Aliens on the landing pad. What if we're the aliens, though? Right at liftoff.
Discovery, go at throttle.
Alright, let me take a look. They do make it look easy, funny man. It's unbelievable. People don't know how big LZ... Yeah, there you go. It's quite large. That looks all right there. So right here, what you're seeing is the liquid oxygen. The condensation from the LOX is going off, and it looks like the plume is illuminating it a little bit. Look at the liquid oxygen trail goes all the way down, and then right when it gets near the rocket flame, it just dissipates immediately, which is pretty funny. Yeah, that looks... I think that's just lighting conditions, dude. It looks fine. Other Falcon 9s have done that. I'm mighty proud of that ragged old flag. Yeah, it's not actually liquid oxygen. I call it a LOX plume, but it's gaseous oxygen. And also it's condensation coming off the booster from the liquid oxygen being so cold. It's like when you take a cold drink out of the fridge, sweats a little bit. Rocket does the same thing. Jeez. Can I just need to see this one more time. So look at how much the grid fins are shaking here. The rocket is coming down so fast that aerodynamic pressure is building up on these things. They're actually it's compressing the air inside of there, and you can see that it's not a uniform airflow, and what's causing, and then the control surface is doing this. They're kind of look like they're vibrating a little bit because you're not getting laminar flow coming off the back of this. That's for sure. See, look at it shake. And then as the air moving over the grid fins goes subsonic, right? Or actually, I should say transonic. What happens is that air is hitting the grid fin, going supersonic, and then as the grid fin punches through it, it compresses it, right, and slows it down, and it goes subsonic, right? So the air on the back side of the grid fin is moving slower than the air on the front side of the grid fin, and that's what makes this crazy effect right here. Ever read that Roscosmos to launch a new VR headset? No, but that's cool. On an unrelated note, Section 7 is hooked up to a Gromny Chunguska. Okay. Horosho. See that? That's, if I'm remembering correctly, if there's any aerodynamics people, that's Prandtl-Meyer singularities, or just the vapor cone. You can see it, especially during the boost back there. Look. So another interesting thing to note is that air on the top side of the booster is flowing at a different pressure than air, or it has a different speed than the bottom side of the booster. So check this out. Look at the bottom grid fins here. The bottom grid fins are catching way more air. Why? Because this thing's flying like this right now. It's flying like that. So the air that's coming on the bottom, right, is hitting those grid fins, and you have a really crazy vapor cone coming off of these. The grid fins on the top, though, the fuselage of the rocket, if the air is coming at it like this, they're not catching as much air. So you can see that the vapor cones on the bottom of the grid fins are way more than they are on the top. Because when you're in the transonic regime, right, when you're halfway between supersonic and subsonic, which means faster than the speed of sound or slower than the speed of sound, there's a window right here called transonic, where some of your vehicle can be breaking the sound barrier and some of it isn't. There's a very good example of it right there. You see? And then as this thing turns, watch, as it turns, you'll see the grid fins start to catch more air, right? And then it gets out of transonic, I think, here. And you can't see the top grid fin. Dang it! Because it would have that cone on it too. It would have just those vapor cones would have happened a little bit later. Because the air is still breaking the sound barrier on top of the booster, but not on the bottom. That's what transonic is. So, like, you don't use, like, ground speed for calculating speed of sound, right? It's all about air speed flowing over the plane, or flowing over the rocket in this case, right? So, keep in mind, like, a wing, with Bernoulli's principle, right? The air, by definition, is moving faster over the top of the wing than on the bottom, right? So, as you approach the sound barrier, obviously, the airspeed on the top of the wing is going to break the sound barrier first before the bottom one does, right? Because the high pressure on the bottom of the wing is moving slower. So that kind of area where the top part of the wing is breaking the speed of sound and the bottom part, that's transonic. That happens with anything that breaks the sound barrier. You have like kind of a weird regime there where you're halfway breaking the sound barrier and halfway not. And you could see those effects happening on Falcon 9. I say effects like it's some kind of 3D or something, right? All this phenomenon happens when it's in transonic. I didn't cover it, awesome, I was asleep. The direct correction there, it seems very violent. Yeah, I mean, those grid fins are steering her. Please check your last. Yep. Of course, how selfish of me. Let's do all the things that you want to do. What's up? Thomas. So Thomas has another bit of info there. First one. Oh, that's okay. We'll get to that in a second. I just had to audio on. Ha! Nice. Nice, Vizio. That's funny. Here, let's flip us back over to live here. And let's see what that tweet's about. Okay, so somebody asked Elon on Twitter, will the first orbital Super Heavy have grid fins? First one to fly will, so Booster 4. Booster 3 will be used for ground testing. We're changing much of the design from 3 to 4. 3 was very hard to build. Expect especially rapid evolution in the first 10 boosters and first 30 ships. I can't believe Starship's actually happening, dude. It's so ridiculous. Maybe the gas exhaust just move away the supersonic flux. You could see the cone disappear when the burns start. That would imply that there's low pressure all the way up to the grid fins, Clembo. And if that was the case, that means the grid fins wouldn't do anything when the rocket engine is firing. I'm pretty sure that it's getting up there in some way, shape, or form. I mean, flow separation. It's not really flow separation. Aero doesn't really work like that. It's not like a column that gets occluded. So if you have the rockets like this, so this is the exhaust, right? It's not a total column. It's more of a cone. And I'll bet you the way SpaceX engineered this is that the cone ends right at the grid fins. So they're probably doing something. Not probably, they are doing something. You can see that here. Yep. I think it's just slowed down enough. It exits the transonic regime when the landing burn starts. Or at least it's getting closer to exiting it. Going down to subsonic.
Discovery, go at throttle.
Buggy on 46-month resub. Thank you. Can you tell me what Elon means here? Starship Super Heavy will not have an entry burn. Delta V is shifted more to the ship. So booster entry pressure and heating is lower. The plain English way of saying that's... Excuse me. The plain English way of saying that tech is that Starship Super Heavy is not going to do as long of a burn. So, like, with Falcon 9, the first stage goes to about 2 minute 30, right? Second stage burns for another 6 minutes after that to circularize. The whole thing with Falcon 9 takes about 8 minutes to get to orbit. Most rockets is about 8, depending on the type of rocket. Space Shuttle took about 8 to 9 minutes, depending on where it's going. Falcon 9 as well. What Elon's saying in plain English there is that the first stage won't burn for as long of a time. Basically, if the first stage doesn't burn for as long, right? If it doesn't burn that much, and it doesn't have to do an entry burn, right? That means you could basically have a heavier second stage. First stage, a lower first stage burn times means that you need a higher TWR on your second stage, but it also means that your first stage doesn't have to go as far. So Super Heavies probably won't fly as far and as high as Falcon 9s do. They might not even break the Kármán line with what Elon is saying there. So they might not go above 62 miles, dude. That Falcon 9 first stage that we just saw, somebody said it in chat, it had a 140 kilometer apogee. That's 90 miles. No, 80 miles up. That's way into space. That's really far. That's a long way into space, so it needs to do an entry burn. New Glenn will take 11 minutes to get to orbit. The low stage 2 TWR is killing it. Expander cycles, Ian. Look at Michael Caine. Yeah, great pictures. Great pictures, Aiden, for sure. RD has a great photo there as well. So that means more refueling flights for lunar missions. More fuel on stage 2 will be used for orbit burn. Yeah, Novus. Yeah, I mean, but... See, here's the thing, man. Here's what I'm thinking. And you tell me if I'm if I got my finger on the pulse correctly here. Starship is base rated at 100 tons. 100 tons into space. And it's just like, it's the same kind of thing going on as Falcon Heavy. So, what's the same kind of thing going on as Falcon Heavy? And Novus, I'm saying this for other people. I know you know this. Falcon Heavy can move 60 tons into space. But Falcon Heavy, so for people that use America units like me, 60 metric tons is 120,000 pounds, give or take. It's a little bit higher than that, but no problem. So, 62 tons, and SpaceX's fairing for Falcon 9 and Falcon Heavy, they use the same fairing. At least right now they do. In the future, they might have they're going to have a special fairing for Falcon Heavy that's a lot bigger. Long story short, with Falcon Heavy's fairing, you're never going to move more. You could fill the fairing up completely with lead, and it still wouldn't equal 60 tons. It could still get it into orbit. Fairing size is key here. Falcon Heavy can move way more into space than anything that you could fit in that fairing. Anything. It could launch a tank into space, a light tank. But can you fit a tank inside of the fairing? No. Now, Novus, I think that Starship it has the same kind of thing going on, and I think the reason why they do that is because if you want to make something reliable, you grossly over-engineer it. If it's way over-engineered for what it's designed to do, you're never going to exceed any operational capacity, right? So, what does that mean in plain English? Starship is base rated for 100 tons. It's never going to move 100 tons into space, ever. I guarantee you, it'll never move 100 tons into space. You can't fit 100 tons of anything inside of Starship's usable payload volume. And like maybe concrete or lead, maybe, and even then, I still don't think that volume is going to be anywhere near 100 tons. So, Novus, you're absolutely right. You're going to be robbed of second stage Delta V. But if you're base rating your performance at a payload of 100 tons, that's not going to matter. If you're moving 100 tons into space every single time, then yeah, you're going to need more refueling. But I don't even think that that's going to happen. I think they rated it at 100 tons, and if those Delta V calculations are based off of at 100 tons rated, right? That basically that it's moving 100 tons into space every time, then yeah, you're going to need a lot of refueling. But I don't think Lunar Starship is, with its usable payload volume, is going to get anywhere near 100 tons. Maybe 10 on a good day. In which case you're grossly over-engineering Starship. But that's fine. You know what I mean? Crane counterweights? Yeah, maybe. Over Thunder, 8-month resub. M1A1 is only 60 tons. Falcon Heavy could put an Abrams tank into space. Don't get me wrong, I'd love to see it. Bradley had a 20-month resub. A couple Bradleys in space. Yep. Over Thunder had an 8er in there. That 100-ton will be the baseline amount of fuel for any refueling. The extra fuel is the payload. Elon's doing some deep math. Okay, what's Elon saying on Twitter here? All right, let's go to the side by side. And you guys can't read that. We've already done a lot of iteration on Starship. For rapid reusability, the booster must return to the launch pad. So inert mass impacts ascent, boost back and landing burns. Triple whammy. Also, booster flight rate is 5 times that of the ship. So multiply mass dollars cost by 5. What was Tim's question here? With more Delta V being on the upper stage, isn't the mass fraction even more important than ever on Starship, and even less important on Super Heavy? I'm surprised to see so much focus on Super Heavy weight reduction when it's the most important thing for Starship. Actually, it's the reverse. Yeah. I mean, that's a good question from Tim. That's a really good question, actually. But no, first stage, believe it or not, first stage dry mass is very important. Very, 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 very important. Yeah, inert mass, it's what I talk about all the time, guys. Inert mass, what Elon's referring to with inert mass there is what's called dry mass on a spaceship design. It's the saying that I always say. If you want your rocket to go further into space, you need more fuel on your rocket and less rocket on your rocket. The more fuel that your rocket can carry, and the less rocket that your rocket needs to carry, means it has, the rocket is lighter and it has more fuel. It can go further. That's the Delta V formula in a nutshell. Rapidly reusable rockets are pirates. More battery, less iPhone. Sure. What about an interstage for a larger Falcon 9 second stage, thus larger fairing for Falcon Heavy? I mean, yeah, Swishio, yeah, sure, you could do that, but SpaceX isn't. They're not going to. They're already making a bigger, way bigger second stage, and that second stage is reusable. There's going to be minor upgrades to Falcon 9 from here on out, dude. We do have the NSSL upgrades, which means a bigger payload fairing, and then that's pretty much it. Ask that question and answer it in not smart person talk.
Go at throttle up.
Willie, that's 1 year. Thanks, man. 12-month resub. All right, so we're almost up to deploy here. For single-use things, stage 2 mass is vastly more important for increasing payload mass. It's a 1 to 1 kilogram trade-off. For stage 2, stage 1 has a lower ratio, which is dependent on the trajectory. I can't speak for reusable hardware. Well, I mean, Novus, with reuse, I'd say that... Let me think about this for a second. I'll keep this open as it has the deployment sequence. Oh, huh. Yeah, so over the next 45 minutes, we're going to watch a bunch of satellites get deployed here. Is it equally as difficult to accelerate payload off the ground as it is to decelerate payload during P2P, point to point? Is it... Was it a good one? Yeah, Theix, here, I'll show you a replay. Here, check this out. The launch was great, but this is what you want to see. So, is it equally as difficult to accelerate payload off the ground as it is to decelerate said payload during point-to-point? No, it's easier to decelerate. Your landing burn doesn't need to be as big as your takeoff burn. Why? Couple of things. Well, one, vehicle's a lot lighter. Okay, come on, SpaceX, let's go. The vehicle's a lot lighter. You're carrying way less fuel, so you don't need to burn as long to zero out your velocity. Second part, aero's going to slow you down. Coming back down into the atmosphere and hitting the atmosphere does the majority of your braking. The space shuttle, re-entry heat. That's why the space shuttle makes drag, for instance, Havix, and so will Starship. Starship will make a lot of drag on the way back. Probably more than the space shuttle, because it's bigger. But yeah, no, it's easier to come back down, believe it or not. But it's kind of like a trade-off. The stuff that makes ascent difficult makes descent really easy, and the stuff that makes descent difficult makes ascent really easy. You know what I mean? Because on the way up, it's really just how much power you have on the first stage. I mean, I'm saying this relatively. Rocket science is difficult. It's really, really freaking hard. It's different things. On the way up, it's like, you know, you want more thrust to get out of the atmosphere as quick as possible. And on the way down, I hope you have some kind of thermal protection system. I mean, you could see the first stage creating drag right there. There it is. That's first stage creating drag.
Oh. Shot of the first stage coming down with its landing burn.
Stage 2 internal guidance.
How's that? Sonic booms.
Stage 1, London leg deploy.
That was as smooth as I'd seen it.
Yeah, that's pretty awesome. Yeah, it's pretty awesome. Yeah. That's pretty amazing. Hang on one moment, guys. The air conditioner is on the fritz, I think. It just stopped blowing cold air a second ago. Like I felt the temperature change of the air coming off that thing. Hey, Battle Tank. Guten Tag, mein Freund. Wie geht's? I would think that since Starship is planned to be reusable, the mass reductions for Starship is more important than Super Heavy. That's from the perspective of payload, though. I don't know about the processing manufacturing costs. Well, Novus, how I explain it to people, and yeah, I think you're right, but how I'm explaining this to people is Starship, and this is the other reason why I think they rated it at 100 tons, or why they're aiming for 100 tons, because it's over-engineered. It's over-engineered in the same way that, so like, okay, how should I say this? You got to think about the engineering like an airplane. Think about Starship working more like an airplane and less like an upper stage. I mean, obviously it is an upper stage, I get it. But the engineering behind it and how it's going together and how it's, like, why it has what it has, you know, on it, where it is, like the flappy wings and the elevators and all the other things that SpaceX wants to put on it, you know. You got to think about it more like an airplane, in that, you know, you're going to take a mass hit. You're going to take an initial mass hit or a dry mass hit on the second stage. That dry mass hit is going to screw your efficiency, but you make up for that in the fact that you can launch Starship a lot because it's over-engineered. The running analogy that I try to explain to people is that a 747 is a great piece of equipment. It would be more efficient if it didn't have any landing gear on it, right? If a 747 didn't have any landing gear, I bet you it could increase its range by a good margin. But then again, the name of the game isn't really always about extending the range, because, you know, when you go to land, you don't have your landing gear. New Raptors just arrived. Check the welds. Oh, very nice. So, I think they understand that. I think SpaceX understands that it's not gonna. They're kind of trying to stray away from you know like conventional rocketry. I mean, as much as they can. Like, you know, you kind of have to blur the line a little bit between airplane and rocket, just like the space shuttle did. If you want to try to make something reusable in the same way that what NASA wanted to do with the shuttle. Going to Mars requires a certain range, though. Planes can stop to refuel halfway. Well, yeah, Sip. That's why Starship is refuelable. That's what Novus was originally talking about. Starship will be able to be refueled very quickly in low Earth orbit, from what I understand. See Thomas's last link. Thomas last. See last link. See last link. Okay, yeah. You guys got to let me finish a thought. You know, it's almost like we're talking about complicated things here. New Elon tweet. Okay, so the new Elon tweet is: work needed between flights is less and less, as shown by shortening time between reflights. Required work between flights for Starship and Super Heavy is 0. Yeah, it's got to be an airplane, man. Just take it, put it right back on the pad. All right. There's a new picture of some Raptors that just arrived. What else do we have? I want to see what the lifting rig looks like for pulling an Abrams out of a Starship post peer-to-peer point-to-point flight. Havocs, that would be insane. Look what's inside of the inner stage. What am I looking at there? Here, let me move this stuff over here. Hey Jay, how many engines does it take to land the first stage? Well, Slater, it doesn't take as many as you need to go on the way up. On the way up, Falcon 9 needs 9 engines, right? It needs 9 engines to push the first stage with all of that fuel that it's carrying, the second stage with all of that fuel that it's carrying, and the fairing and the payload and the computers to make the whole thing work, right? You're moving a lot more up than you are coming back down. So Falcon 9, on the way up, you're going to need 9 engines. But on the way down, for the landing burn, so like we're talking about the one where it deploys the landing legs and comes back down, you only need 1. And even then, Slater, you only need 1, and that engine needs to be at half throttle. That's what I mean about the less rocket you can have on your rocket, and the more fuel you can have on your rocket, the further you go. That's a plain English way of saying basically the rocket equation, which is the delta V formula, which is how far spacecrafts can go. Like, it's the math behind how far a spacecraft can go in space, right? So, Slater, it needs 9 on the way up, but 1 Merlin engine on the way down. Like, when they first fire it, it fires at full throttle, and then they throttle it down as they get closer to the ground. Merlin 1Ds are capable of what's called deep throttling. So, deep throttling is any rocket engine that can go down below like 40% rated thrust. Yeah, that's not easy to do with a rocket engine. Yeah, that's not easy to do. So yeah, it doesn't even land on one engine. It lands on one engine that's like at half throttle. Pretty crazy, huh? Okay, we're getting up to second stage engine start here very soon. It's not really over-engineering for the sake of over-engineering for aerospace. It's about building in a certain factor of safety for maximum expected loads. Too much mass is less efficient, but too little mass affects it. Too little mass risks failure. You got to hit a sweet spot, of course. All right. We haven't seen an increase in the speed here, or unless I missed it.
Nominal orbit insertion.
Okay.
So we did have successful second engine start for the second time and successful second engine cutoff, and you just heard the call for a nominal orbital insertion.
Right, cool.
So the second stage is going to coast for a few minutes before we start to deploy our satellites. And as I mentioned, this is our second dedicated rideshare mission. Our goal with these rideshare flights is to provide small satellite operators with competitive pricing, increased flight opportunities, and flexibility. These dedicated rideshare flights to sun-synchronous orbits will occur about 3 times a year, providing regular access to orbit. In addition, we also offer opportunities for ride to orbit on our Starlink missions, which launch every couple of weeks. We've launched 4 Starlink missions that include rideshare spacecrafts as well, and we're hoping to launch much more in the future.
How many electrons does it take to do one transporter?
So coming up in about 2 minutes, we are expecting the start of the deployment sequence. There will be 31 deployments for 88 spacecraft, which will occur over a 30-minute period of time. This includes CubeSats, microsats, and orbital transfer vehicles, sometimes called space tugs, which will deploy their spacecraft after separating from Falcon 9, and also 3 Starlink satellites. Many of these deployments will be grouped within seconds of each other, while others may be a minute or more apart. This is a look at the order of deployments between now and the final deployment around the T+1 hour and 27-minute mark. You should hear the call out from our mission operators as each deployment happens, and to keep in mind, most of these deployments include multiple satellites. So while there are 31 deployments, at the end we will have put 88 satellites into orbit, again including our 3 Starlink satellites.
I don't know what the exact classification for a microsatellite hypersonic. I mean, if a CubeSat is 10 by 10 by 10...
We are about a minute away. This is a view of our second stage.
Reacquisition of signal.
And back to the animation. Several of the customers on board this mission have multi-launch agreements with SpaceX. So some of the names might sound familiar to those of you who have tuned in for previous rideshare missions. It's also worth noting that we will lose access to ground station coverage for a short period during the 30-minute window, 30-minute deployment sequence.
30 minutes.
When we reach that point, we'll let you know. And here's the view of the second stage MVAC engine. Similar to the first transporter mission, we'll be flying a fuel dome payload tray, which is essentially a small platform mounted on the back end of the second stage fuel dome that will release a handful of payloads. And as you may have already noticed, one of our 2 MVAC views is obstructed because of that fuel dome payload tray.
Acquisition of signal, Bangalore.
So we are expecting the first batch of deployments to begin in a few seconds here.
All right, let's see if we can see one pop off here.
Phase 1, separation confirmed.
Okay. Nice, Forge. No problem, Slater.
NewSat 19, separation confirmed.
Okay. Hey, Nubius.
First ISI satellite, separation confirmed.
Jeez, they're freaking going ham on the deploys. You'll see. So see this central kind of cylinder in the center? Those are payload attachment fittings. So they basically have a huge column, right? And then they have a bunch of satellites bolted to that column. All these square things on the sides are all different satellites. Oh, little 7th tower
Tropics
section.
Pathfinder, separation confirmed.
Okay.
Domes 2.
Hey,
separation
there it
confirmed.
goes. Cool. Where can I find the release fix for KSP? 11 or 1.12.1 is not the ground anchor fix, Joe. Was that a moth in the background? It's most likely either a piece of solid nitrogen nulty from the reaction control systems or some solid oxygen that was purged off of the M1D vac. This looks like a pretty big payload. Nubius, there's 88 satellites on board here. It's big in volume, small in mass. Okay, we should be hearing a report for another deploy here. What's that white light? The moon? I think. I'm pretty sure that's the moon. If it was the sun, it would be a lot brighter. Why did they cut away right after? Hey! There it goes!
Second ISI satellite, separation confirmed.
That's cool. Oh, that's neat.
TIVAC 0211, separation confirmed.
Yeah, no, it's aliens. Sure, that's what everybody wants to hear.
YAM 3, separation confirmed.
Okay.
Tubin, separation confirmed.
Oh, there it goes. Did you see it? I'm sorry, I don't know. It looks so funny to me. Oh, there goes another one.
Umbrasar, separation confirmed.
Dude, we gotta have like an external camera seeing this, just seeing the thing just...
Ion satellite carrier, separation confirmed.
Bye-bye. They're just rifling off satellites. This is awesome. That's so cool.
So we saw a couple of satellites, and we got confirmation for the NASA's PACE-1.
Why is it funny?
Satellogics NewSat-19, the first ICE-I satellite from an exoport. NASA's Tropics Pathfinder, Planet IQ's GNOMES-2, the second ICE-I satellite from an exoport. TIVAC 0211, Loft Orbital's YAM-3 from an exoport, and TU Berlin's Tubin from an exoport.
So anyways,
the Umbar
I started
SAR
deploying.
and D-Orbit's Ion satellite carrier. We were expecting to hear the call out for TIVAC 0173, so we're going to check in with the teams and see if we can give you guys an update a little bit later.
It's competitions.
Coming up, we have another batch of 5. These are going to be for the Space Development Agency General Atomics Peritons Lynx 2, Satellogics NewSat 20 and 21, Capella SAR satellite, and the third ICE-I satellite from an exoport.
That was English. Just thought I'd let you know.
Lynx 2, separation confirmed.
You need help. How does the release mechanism work? It's a spring. Latch in a spring, Felderman. Seriously, like, it's just a spring. Like, there's like a little latch that's actuated on a solenoid. The latch opens, springs decompress, shoot the satellite away. It's that simple. There goes that one down there. You know
NewSat 21, separation confirmed.
We need it. It makes sense.
Capella SAR satellite, separation confirmed. Third ICE-I satellite, separation confirmed.
So we got confirmation for...
Expected loss of signal, Diego Garcia.
We got confirmation for 5 more deployments. That was the Space Development Agency General Atomics Paraton's Lynx 2, Satellogic's NewSat 20 and 21, the Capella-SAR satellite, and the third ICE-I satellite from an
Cool,
exoport.
buddy, yeah.
For those that are wondering,
We deliver.
exoport is an adapter, special adapter built by our EXO launch customer. We are about halfway through the 31 total deployments on today's mission. And coming up, we have 2 more deployments. These are going to be for the Space Development Agency General Atomics Lynx 1, as well as the DARPA Space Development Agency Air Force Research Laboratories Mandrake 2.
I think it's just where it can fit, goalie, to be honest with you. Probably, Panta.
Lynx 1, separation confirmed. Mandrake 2 able, separation confirmed.
Later!
We
Abracadabra,
got
Holmes.
confirmation for Space Development Agency General Atomics Paraton's Lynx 1
I haven't seen it,
deployment,
but we'll show it later.
as well as the DARPA Space Development Agency Air Force Research Laboratories Mandrake 2 able. And coming up in less than a minute, we are expecting the next deployment. It's going to be the 4th ICE-I satellite from an exoport.
Okay, still got plenty of satellites on here. And then
Fourth
check
ICE-I satellite, separation confirmed.
later.
And that was confirmation of the 4th ICE-I satellite from an exoport. The next batch of deployments, there's going to be
I like
6
those
of them.
3 Starlink
It is
satellites that
for
are up there.
Swarm's 1st and 2nd Space B cluster from an exoport, Nano Avionics D2 Altacom 1 from an exoport,
They'll deorbit.
Spire's Lemur number 1 from an exoport, Satellogic's NewSat 22, and Loft Orbital's YAM-2 satellite.
Yeah, see those things up there? This thing at the very top? Not this, not that. There's 3 Starlinks at the top of the payload attachment fitting, guys. Chiba, there's so many satellites like this, so it sounds like a very lucrative launch for SpaceX. And think of it this way, dude. They reused the fairings in the first stage. This thing literally cost them some operations cost, a second stage, and some fuel. Right, Electron? It's true.
First Space B cluster, separation confirmed.
No problem, Omega. It's cool, huh? I live and breathe this stuff. If I could breathe space, I would, but don't do that. But yeah, thanks, man. I appreciate it. So,
Second Space B cluster.
oh, there,
separation
dude, that one
confirmed.
bees. Did you see that? That thing was out quick. It was just like, nah, I'm gone. All right, I'm gonna head out.
D2 Atacom 1, separation confirmed.
Roger.
Lemur number 1, separation confirmed.
Lemurs. Yeah, Andy said it. Yeah, Andy said it too. They had no confirmation for Tyvak. What are these things? They're small satellites. Where will the stage deorbit at?
NewSat 22, separation confirmed.
Probably over the ocean somewhere.
YAM-2, separation confirmed.
Yeah, exactly. That's actually not a bad idea.
And we got some really cool views of the satellites separating. That was for Swarm's first and second Space B cluster from an exoport. Nano Avionics D2 Altacom 1 from an exoport. Spire's Lemur number 1 from an exoport. Satellogic's NewSat 22 and Loft Orbital's YAM2 satellite.
Yeah, TJ. I know, right?
The next two deployments are going to happen during a blackout period, which means that we lose camera views and telemetry. While we wait to regain access to ground station coverage in a few minutes, sit back and follow along with our animation that shows you where we're at in the mission. We'll see you back here at the T+ 1 hour and 15-minute mark.
Okay, we got a little bit of a blackout period. It looks like they don't have a ground station in Russia.
Expected loss of signal, Bangalore.
Okay, so right now, the booster is kind of... It's like on the border of Western China and Kazakhstan. It's going north up to the Russian border here.
Discovery, go at throttle up.
Almost Yost, 6-month resub. Now, the Gobi Desert is a little this way. Gobi's over here.
Discovery, go at throttle up.
Airborne, 34-month resub. How you doing? Kerbal King, what's up, buddy? 34-month resub.
Discovery,
I don't know. Karate, maybe. It's actually kind of close to Baikonur. The Baikonur Cosmodrome is right here. Would it matter for the mission if they launch north instead of south? Yeah, Georgia is in the way if they launch north, hip-hop. So yeah, it does matter. In terms of just straight performance, no, not really. It's going good, Kerbal King. How about you? That poor lake, that's the Aral Sea, or what's left of it. I made an expensive mistake. I found this on eBay and now I want it. Cool. Noted, Endo. Well, with the anomalies and the other launch sites and stuff, and Kerbal exploration, you might, with anomaly hunting in mission mode, you might see a little bit more plane design. Any good launch pads to be able to launch north? You can launch north out of Kourou, the Europeans. In fact, when they do polar orbits, that's what they do. They launch north. Okay, over Russia right now. How many years until NASA starts launching a human lifespan in space experiment? I don't know. We're a little ways off from there. Could the Alaska site not launch north? No, the Western testing range is... no. Don't take the chance, Hokie. How's your week? It's great, man. How about you? Okay, we're making up, making our way north. Kind of near the Kola Peninsula here. We're a little bit to the east. Yeah, Geezer, of course. Everybody tracks everybody else's stuff, dude. It's a way to hold accountability in the space program from different countries. Everyone tracks everything. The Russians are tracking us, we're tracking the Russians. Chinese tracking Russia and us. We're tracking the Chinese, the Russians track the Chinese. Europeans track everybody. Yeah, that's a good way. It's a good way to keep, like, stay accountable in space. Keeps everybody honest, that's right. So I have a question. How did the 88's launch go yesterday? Oh, it went terrible yesterday because it didn't launch. It launched today, though. You're watching it right now. I'm not sure, Phil. Andy said he'd give us an update with it. How's progress? The progress launch, I didn't watch it. I was doing something else yesterday. I saw Virgin Orbit launch this morning. Great launch. Yep. Okay, we should be coming up here. In fact, for most launches, we're required to tell other countries. Yeah, Hokey. I mean, not required. It's you don't have to tell them about a launch, but it's pretty good to let them know, especially countries that could interpret you launching something as something else. Yeah, how about we don't do that? Progress missed the Starlink by 500 meters. And then a Falcon 9 stage joined the chat at 1.5 kilometers.
Welcome back to the webcast for Transporter-2, SpaceX's second dedicated small-sat rideshare program mission. On board this mission are 88 spacecraft, including 3 Starlink satellites. We are currently waiting to hear callouts for 2 deployments, which occurred during a blackout period with no access to ground station coverage. So those 2 are Spire's Lemur number 2 from an exoport and DARPA Space Development Agency Air Force Research Laboratories Mandrake 2 Baker.
Honk honk. Close call will happen tomorrow before docking approach. Oh, okay. Hey, Slater, Tier 1 sub. Thank you very much. I'm not sure it's necessarily part of a treaty, Hokey. It's just more everybody announces that they're launching things, that's all. What's an exoport? I'm not 100% sure.
Lemur number 2 and Mandrake 2 Baker, separations confirmed.
Acquisition of signal, Svalbard.
Svalbard.
And there was the confirmation for Spire's Lemur number 2 from an exoport, the DARPA Space Development Agency Air Force Research Laboratories Mandrake 2 Baker satellites.
Honk honk.
Coming up, the next 2 deployments will happen a few minutes from now. Those will be for Spaceflight Incorporated's Sherpa FX2 and the LTE-1 satellites. And we're going to leave you with a short animation and sit back and follow along, and we'll see you back here once we hear those callouts.
So I have a final tonight. I could take it tomorrow, but not sure. A lot of information to compile. Take it when you're ready if you have a choice. Nice, Steven. That's cool. Svalbard. Yep. Using a Norwegian ground station. I'm going to go ahead and guess that that's probably near Ndoya. Nice, everyone. That's good. Exoports are ports of a port, essentially. Exolaunch buys a slot from SpaceX and Exolaunch builds an adapter and sells these slots to customers. Got it. Is there a ground station in Alert? I don't know what that means, Vixit. Svalbard is a Norwegian island. So, okay, so it's not near Ndoya. Well, it could be. Not like next to it. Exactly, geezer. Cool, Seth. So I've seen the 10-year anniversary video of Kerbal. You were in it several times, and I believe I was watching when those clips were taken. You weren't. I did an interview with them off stream, dude. I just said what I usually say on stream on that, though. Yeah, I did an interview with him like a month ago or something. Hopefully it leads to some better things, man. It's called the Kerbal Effect, Ivo, on YouTube. What is new in Kerbal? There's a bunch of stuff, man. The patch notes are floating around. Somebody could get airborne the patch notes. Yeah, there's a bunch of small stuff. Is it gonna help you make more epic content? Sure. Kerbal Existing does that, airborne, but yeah. Sure.
Discovery, go and throttle up.
Look at that view. It's one heck of a view, guys. Hey, TRP. Tier 2 21-month sub. Yay, satellites on sub day. Thanks.
Acquisition of signal, Thule.
Thule.
Welcome back once again to the webcast for Transporter-2, SpaceX's second dedicated small-sat rideshare program mission. We have two deployments coming up. These are going to be the last two for our rideshare customers. They are for Spaceflight Incorporated's Sherpa FX2 and Sherpa LTE-1. And that should be coming up in about 20 seconds.
Maybe Hokie. And keep in mind, Hokie, I said I'm not sure if there's a treaty. That meaning somebody should go look that up, you know? Yeah, I figure I could look that up. Okay. Should be coming up on a deploy here. Yeah, yes, it does, Hibbit. Mm-hmm. Nice, Queer. Tell you what I'd do. Violate 2 treaties at the same time, man. And dang straight I was wanting to do that. Falcon 9 took 2 years worth of small sat launches market in one launch. Heard nothing here. The comms are pretty silent. Yeah, Starlinks are all the way.
Sherpa FX2 separation confirmed.
Nope, there it goes. Bye-bye.
Sherpa LTE-1 separation confirmed.
Oh, that's so
And
cool.
you see on screen and heard the confirmation. We got confirmation of Spaceflight Incorporated's
Bye.
Sherpa FX2 and Sherpa LTE-1 deployment. Now, these are the last of our rideshare deployments for today, but we're not done. We have 3 Starlink satellites to deploy as well. That's going to be coming up in a few minutes here, so sit back. We're going to take a quick break, and we'll see you back here at the T+ 1 hour and 27-minute mark.
Going over the northern coast of Greenland right now. Yeah, Phil, I got you. the music with the views, man, that just makes it. They'll deorbit the stage, Canadian, if that's what you're asking. Yep. In fact, they usually stop the webcast, but they usually deploy it maybe an hour, or they usually deorbit like an hour after the mission. Depends on the mission. Yeah, look, you see all the dispensers? That's cool. On the northern coast of Greenland here. About to cross into Canada. Can we still see Tyvek on there? Can we see the Tyvek satellite on there, Thomas? Is it in any of the views?
Discovery, go and throttle up.
Franco Schmidt, 22-month resub. Thank you. What it looks like if you want to try and spot it. Oh, it's in a dispenser. Yeah, that's going to be hard to see if it's inside of the dispenser. That's crazy, Couillard. Oh, a little bit of solid oxygen coming off the engine there. Yeah, they're gonna spin it to. They're gonna spin the thing to deploy the Starlinks. It's automatically done, airborne. They'll deorbit it, Karate, yeah. Isn't today Asteroid Day? Is the asteroid mission still a go? Today is Asteroid Day. Oh yeah. We're gonna go for it. The question is, Platinum, should we do it? I don't know. Should we do it in mission mode or should I do it in engineering mode just to show? I'm not sure what we can do in mission mode, but how can you tell if it's solid oxygen or nitrogen? If it's around the engine, there's a good chance.
And welcome back to the webcast for SpaceX's Transporter-2 mission. If you're just joining us, we are close to the end of today's mission, which launched this morning from Cape Canaveral Space Force Station in Florida at 3:31 p.m. Eastern Time. We then had 2 successful ignitions and shutdowns of the second stage Merlin vacuum engine, then successful deployment of a majority of our spacecraft for our commercial
0173,
and
separation confirmed.
Government customers. We were also able to vacuum engine, then successful deployment of a majority of our spacecraft for our commercial
0173,
and
separation confirmed.
Okay, there it is.
So all payloads so far are have been confirmed for deployment. We have 3 Starlink satellites to go, and we are expecting confirmation of that deployment here shortly.
Stand by for the Starlink deploy. That's those things at the very top.
Expected loss of signals, forward.
They're going to spin it to win it because Starlinks don't have a deployment mechanism. They're just basically clamped to the top of the payload dispenser, and then they just let the clamps go. There's nothing to push it away. What SpaceX does is they spin the stage, and the spinning force pushes, the angular momentum pushes the satellites away. All they do is just undo the latch. You had to keep it simple. So you should see a little mini tensioner rod separate right here. There they go. Bye-bye.
Starlink deploy confirmed.
And there goes our 3 Starlink satellites. Again, that is 88 spacecraft confirmed for deployment on today's Transporter-2 mission. With that said, we will be bringing our webcast to an end. We would like to thank all of our rideshare customers for their support on today's mission. We would also like to thank the United States Air Force for range support, as well as the Federal Aviation Administration for licensing. Continue to follow us on SpaceX.com for future missions and milestones, as well as our Twitter and Instagram profiles. And if you are excited by what you've seen today and want to join our team, visit SpaceX.com/careers to learn more about working at SpaceX. And as always, thank you to all of our viewers for your continued support, and have a great rest of your day.
Yeah, you too, Andy. Not bad. Is that the most ever? No. Funny story, just on a side note, you know, taking a bunch of small payloads and putting them on a big rocket, that's not the first time this has been done. The space shuttle used to do that. In the 80s, the space shuttle had what's called a getaway special program, and what basically what the getaway special did was, if the shuttle had leftover payload bay volume, so if the primary payload was only 10 tons, that gave them 10 tons of aggregate space. So they'd just put more satellites in. Yeah, getaway special. They used to fill up extra spots on the space shuttle with satellites. Yeah. Stopped doing it, I think, after Columbia. But yeah, smart idea. Peter Beck must be super salty. Well, he's the competition. I don't think it's salty. It's just, yeah, just kind of, hey, that's your competition. Do better. See if you can. It's friendly competition. They don't. It's not like they hate each other, you know. All right, guys. Well, that was the Transporter-2 mission. It was awesome. I think we're going to do the, just on a side note, I think we're going to do the asteroid redirect in mission mode, and it'll be an emergency fund. And it will basically I'll launch it at cost. Okie dokie? We're going to do space news now, though. And, yeah, we'll go from there. Okay, so I'm gonna take about 15 minutes. I'm gonna go grab something to eat here. Gotta take a little bit of a break here. It is a long stream. We still got plenty of stream left. Probably another, I don't know, 6-7 hours, something like that. 5. Well, it's closer to 5 or 6. But plenty of stream left. We got Kerbal. We got Asteroid Day stuff in Kerbal happening, and we also have space news coming up. There's a bunch of space news that have happened. 2 rockets have launched since the last time I streamed. Before this stream, the last time I streamed was less than 24 hours ago. We had Virgin Galactic and Progress MS-17. So, yeah, bunch of good launches. We'll watch that for space news, and yeah, we'll go. I'll see you guys in about 15 minutes. Make sure you budget for Bruce Willis. Okay. Find something that will impact and declare an emergency. Maybe. Did you know that small sats aren't really insured? Oh, interesting, Phil. Do we know what's the total revenue for SpaceX for this launch? Don't know. I have no idea, Swishio. Anyway, yeah, we'll probably never figure that one out. SpaceX isn't publicly traded, dude, so who knows? Anyway, I'll be back in 15, dudes. Don't go anywhere.
Go and throttle up.
I'm not done, but the song's over. I'm not done eating. Did you get all the space? Yeah, I did, but I gotta finish eating, man. One more time? Yeah, one more time. Okay. When this song's over, on the other side of the song, that's when we'll start Space News.